Hi there, Pre-Calc lads and lassies. Getting toward the end of Chapter 1 here. This is perhaps one of the more challenging lessons on something called piecewise functions, something you may not be quite as familiar with, but let's give it a go, see what we can do. Piecewise functions are kind of a break in the graph. There are several different functions perhaps graphed on the same grid, as we'll see. We'll show you how to do them by hand and also show you some neat things to do, how to do them on your calculator. So here we go. Let's look at our very first piecewise function here, which usually when you see these in the book here, there'll be kind of some brackets around there like this, meaning that this f of x function really has three different parts. And so the idea it's three different functions depending where you are on the grid, and especially we look at the x values, and we'll just see if we can graph this by hand. So we'll do this in different colors so we can have a good feel for this. So first of all, we're going to do the first part here in red. Notice what this says is f of x equals 2 when x is less than or equal to negative 5. Well, 2 is just a constant function. A constant function will just be a straight horizontal line. So we're going to graph this at positive 2 when x is less than or equal to negative 5. So it's going to look something like that with an arrow going to the left. Okay, notice the less than or equal to, there is a solid dot here at negative 5, meaning that point is included there. Alright, we're going to change colors here, and let's look at the next part. Now x plus 4 when x is between negative 5 and positive 4. So I think I'm just going to kind of go one by one here. This will be just a straight line, but for instance when x is negative 5 plus 4 is negative 1. So negative 1 will be graphed. However, because of this just the less than sign here, I'm going to put an open circle down there at negative 1. So that's supposed to be an open circle. Meanwhile, then we'll just kind of go down the line. So let's say if the next one at, oh, let's say negative 3. So negative 3 plus 4 would be positive 1. So there I have a dot right here. Let's go to 0. 0 plus 4 is 4. And finally, let's go to actually positive 4. 4 plus 4 is 8. So the point 4, 8 would be graphed. So that's way up here. And notice that's a less than or equal to, which means that that point is included. I'm going to connect all these up so it looks like this. Alright, so far so good. We're just doing this piece by piece, so it's a bit of a pain, but that's what these piecewise functions are all about. Last one here with the blue line, negative 0.5x when x is greater than 4. So if I just substitute 4 in here, 0.5 times 4 is 2, with a negative sign will be negative 2. So the point 4, negative 2 will be on the graph. However, it will be an open circle because of that greater than sign there. Let's just go to another point like 8. If I put 8 in here, 0.5 times 8 is 4, but it's going to be negative 4. So the point 8 and negative 4 will also be on the graph. So it's a downward sloping line that looks like this. So that's our first piecewise graph, kind of a screwy looking thing, but as you can see it's a different function for each piece or each x value, each x interval of the graph. Now here's how you do this on the calculator. And I'll try to point out this a little bit. So here's the keys of your calculators. Obviously you're going to go to your y equals key here. And notice how I entered these. So the key thing to really watch out for is you need lots of parentheses. So when you're graphing or putting in the 2 there, you have to have the 2 in parentheses. And the condition here, the x less than or equal to negative 5, that has to be in parentheses as well. Now, where do you find the less than or equal to sign? Well, how you get to that is go to Second and Math. Second and Math. You get to this Test menu, and you'll see all those inequalities there. So you can just enter them like that. The other tricky part is when you get to the second option here, which is the interval between negative 5 and positive 4. Notice when you enter this in the graphing calculator, you have to split that up into two inequalities. that does mean that x is greater than -5, and also that x is less than or equal to 4. So you have to split those up, each in parentheses. And here's the last option there, the -0.5x. Now, good thing to do is go to zoom. The zoom key is right here. Go to a standard window. That's always from -10 to 10. That's typically where we'll be graphing these things. And so you can see there's the graph. Looks pretty similar to what we'd come up with on the previous slide, but the calculator does it. So you can use your calculator on these, but sometimes it's more of a pain to enter in all this stuff in the calculator than it is just to do it by hand. We're going on here a little bit. Another classic piecewise function is called the greatest integer function. The greatest integer function. The domain can be any real number, decimals, fractions, positives, negatives, but the range is the greatest integer not greater than x. Not greater than x. So let's think about that a little bit. Here's the symbolism, and actually our textbook will kind of put another little line over these double brackets like that, as you'll see. But anyway, we would read this: the greatest integer of 3.8 is 3, because it's not quite up to 4. The greatest integer that's not greater than 3.8 has to be 3. So sometimes on the greatest integer function, it's sort of helpful to think of it as a rounding down. So you're not rounding in the classical sense that you're used to, but you're rounding down to the next greatest integer. So the next one here, we can see the greatest integer of 4.2 is 4, because you have to round down to 4. Now here's a tricky one. Let's see if anybody can get these. What do you think the greatest integer of -2.8 is? Well, you have a feel for it. It's either going to be -2 or -3. And actually, remember, it has to be not greater than x. So the correct answer here will actually be -3. Kind of strange. And how about this one? -7.1. Again, think of where that is on the number line. If we think of an integer not greater than that, we have to say that the answer here is going to be -8. Here's a classic graph of the greatest integer function. Notice the filled in circles are on the left and the open circles are on the right. And if you think about this definition and what it means, that'll make sense why it looks that way. Now, for the integer on your calculator, it's the INT option under math. So the math key is right here, way in the left column. If you go to that and then get under the number option under that, sure enough, there's that INT. When you go to your y equals and graph it, you do have to put an x in there, and sure enough, the graph will look like this. And the only disadvantage of the graph and the graphing calculator is you don't see the open circles and closed circles and things like that. But that's something that you can figure out easily enough, I think. So that's the greatest integer function. And the one we're going to look at is the absolute value function. That's another pretty famous piecewise function example. Again, the domain could be anything: positive, negative, nice number, not so nice number. Range must be non-negative. Reason we say non-negative is because 0 could be an answer here. So I like to think of the graph bouncing off of the x-axis. You'll never have anything graphed underneath here in an absolute value function. So we have that characteristic V shape. Won't always look perfectly V like that, but it will be always some variation of that depending if you have anything else inside the parentheses there. So on the calculator, again, it's under this math menu, quite similar to where that greatest integer function is. So math, ABS, again, you have to get that x in there, or any other kind of configuration, and sure enough, there's what that graph looks like. So in this lesson, we'll be graphing several types of piecewise functions. The one we start out at the start of this lesson, those are the toughest kind, I think, but there'll be a number of other variations of this. So keep plugging away at this, and we'll practice on this some more in class. Bye now.